Hello everyone. This is the presentation for Engineering 990A on the topic Integrative Optimal Framework for Hybrid Power Systems, Design, Analysis and Sustainable Solutions for Pilley Island, Newfoundland. I, Abhinav,
And me, Sahil Kumar.
And Sahibjeet Bangar.
are going to present this presentation. The agenda of this presentation is to start with the introduction, then reviewing all the literatures that are related to hybrid energy, then giving particular information about Pilley Island, and after that, we have proposed our hybrid system for Pilley Island using Homer Pro, and the dynamic analysis is done in MATLAB. And we end with the results of MATLAB and then conclusion. The world right now is facing growing concerns over environmental sustainability driven by climate change and the depletion of finite fossil fuels. This has promoted a global shift towards adopting renewable energy sources to reduce greenhouse gas emissions and mitigate environmental impacts. So, for remote locations like Pilley Island, it often faces challenges establishing conventional power infrastructure, leading to increased reliance on costly and polluting diesel generators. So, to address this challenge, we have created a hybrid power system uh, emerging as a promising solution. By combining renewable energy sources such as solar and wind with energy storage technologies, we can create a robust and sustainable power supply. Pilley Island specifically is located in the remote region of Newfoundland, facing unique challenges due to its geographic isolation and limited access to conventional power supply. The primary objective of our research is to develop an integrative optimal framework for designing and analyzing and giving sustainable solutions for hybrid power systems tailored to Penny Island's energy needs. We employ advanced software such as MATLAB Simulink for dynamic analysis and Homer Pro for steady state analysis to assess the feasibility and performance of our proposed hybrid power system. So, through this research, we aim to advance sustainable and efficient energy solutions for remote areas like Pilley Island. The insights gained from our study will not only benefit Pilley Island but also provide valuable guidance for similar applications in other remote locations seeking sustainable power solutions. The finding of our research will inform policymakers, energy planners, and stakeholders about the viability and benefits of adopting hybrid power systems as a means to achieve a transition towards a more sustainable and resilient energy future.
Okay, thanks Abhinav. After introduction, I'm going to start with the literature review. Growing popularity of renewable energy resources. The various forms of clean energy are recognized as a prominent source of renewable energy. The increasing worldwide interest and investment in renewable energy have contributed to progress and popularity of these resources. This growing commitment to clean energy reflects a global shift towards a more sustainable energy future. Now, the PV diesel generator hybrid system in Indonesia. A study in Indonesia focused on the design a hybrid system combining photovoltaic PV and diesel power generation. The objective was to conduct a comprehensive analytical investment to identify the optimal design. Simulation using Homer software and subsequent evaluation from technical and economic preservatives were carried out. The sensitivity analysis was performed to assess the system's response to load and fuel cost variation. The hybrid energy system with improved EMS. Zhang and Yukil are the true researchers who analyzed the hybrid energy storage system with hierarchical control methods and microgrid control system. An improved energy management system for a hybrid storage system with two batteries and supercapacitor was presented. The study focused on islanding state and application in a remote solar photovoltaic installation on Hong Kong island. The implementation of solar PV He replaced diesel generator, resulting in reduced fuel expenses and environmental pollution. The various components, including PV array, inverter, battery, and so on, were analyzed for energy performance. The performance analysis of solar photovoltaic power system. The system represent the result of long-term system monitoring and assessment of the solar PV system on a fairway island. The technical difficulties and operational performance of the system were comprehensively analyzed. The key aspect examined include daily energy balance, normalized performance metrics, overall system energy utilization ratio. And now the solar photovoltaic power system at Sagardeep Island, India. A case study of solar PV system at Sagardeep Island, India focused on the technical financial metric for the performance analysis. The study also explained how the PV installation affected social interaction and improved the quality of life for inhabitants. Large scale operations were identified based on well established technology, easy of use maintenance, MOS reduction, and environmental sustainability. The SPV system was considered a competitive alternative where demand was moderate and conventional power solutions were not economically feasible.
Thank you, Sahil. So now I will discuss about our location which we have chosen. So we have chosen Pilley's Island, which is located in Newfoundland and Labrador. It is a coastal area with a rugged territory and relatively small area, which is primarily a residential community located in this area. So it is if we check about its energy demand, so winter month experience high peak load due to heat which is needed for house, and while the summer month witness reduce in energy demand. The peak load, the daily peak load, the energy system peak at 408 kilowatt daily, required a total energy consumption of 2422.06 kilowatt hour. So renewable potential. So as we are making a hybrid system, so we will considering a solar energy, as solar it has good potential on this island, and also we are, as it is located in a coastal area, so it has great wind energy potential as well. So in this project, we are focusing on hybrid power design. So our project objective is to design an optimal hybrid power system that balance renewable energy variability and increase demands and energy demands. Approach of this project is to employing MATLAB simulation and Homer Pro for dynamic and steady state analysis respectively. And after that we will assess the system response to the various loads and fuel costs for our system. Economic feasibility, so the cost benefit analysis. So in that we are doing a cost evaluation and potential cost saving comparing to traditional diesel generator, and also we are considering the environmental impacts, analyzing the reduction of carbon emission and overall environmental benefits of the renewable energy system. The Pilley Island present a unique energy challenges and opportunity for the sustainable power solutions. The research aim is to develop an integrate framework for the for powering this remote island for clean and efficient energy solution.
This is the steady state system design for our uh, project for Pilley Island. We have chosen photovoltaic array, battery system, inverter, backup diesel generator, and wind turbine. So this is the specifics that we have chosen for PV array. and the rated capacity is 1161 kilowatts, and its capacity factor is 13.6%. So from solar array, we are going to generate 138,138.5 kilowatt hour per year. These are the specifics for the diesel generator. So a diesel generator will be producing the lowest amount of energy, which is a good thing, and the annual electrical production will be 2129 kilowatt hour per year. So for the battery, we have used 174 batteries in parallel for storage needs. .540 kilowatt is the rated capacity for the wind turbine that we have chosen, and the total production per year will be 621,683 kilowatt hour.
Now coming to electricity production summary, as shown in the graph, the PV production. Now coming to the dynamic model of our system in MATLAB, as you can see our MATLAB, on the left hand side there is a diesel generator connected with the grid connected solar PV array, and on the right side is the wind turbine, all connected to a transformer with two critical loads and one non-critical load. And after that we combine all these supply and power and give power to the main grid. The simulation model and the components we use are the MATLAB Simulink used to analyze dynamic behavior of integrative optimal framework for a hybrid power system tailored for Pilley Island. The components: main grid connection, rated capacity of 154 megawatts, voltage rating of 34.5 kilovolts. Step down transformer is used also, in which the lowering grid voltage to 400 volts for integration with the hybrid system. The primary energy sources are PV panel array with 41 kilowatts, PMSG wind turbine system with 1.5 megawatt, diesel generator 430 kilowatt. The control mechanism we use MPPT for PV, grid side and machine side converter for wind turbine, the diesel engine governor for the generator. The microsystem supplies the power to the two critical load and one non-critical load with specific power rating. Now the simulation result. The first one, I will show you the effective integration of diverse energy sources. The grid power observed as negative, indicating power being supplied to the grid from the hybrid system. The solar power generation, PV system contribute around 40.5 kilowatt, demonstrating efficient solar energy utilization. The wind power generation, the wind turbine system contribute approximately 1.5 megawatt, showcasing successfully harnessing of the wind energy. And here we can see the block diagram which I made on the MATLAB, and that's combination of the grid converter and mechanical side converter with our diesel generator.
Now we will discuss reliable backup power resources. So first of all, diesel generator. So diesel generator is used for 25 kilowatt as a backup when there is low renewable energy availability. So it depends on the weather when whether we should on the generator or not. So now we will discuss about effectivity, and the hybrid system successfully integrate for the renewable resource, and a diesel generator addresses Pilley's Island energy challenges effectively, provides a robust and sustainable electricity supply for the community, reducing the use of fossil fuel and promoting the good environment. So as we can see in this diagram which we made on Visio. So we have used P and O algorithm for MPPT, and solar is connected, and a converter and inverter is also used, which is directly connected to the grid. And as we see the output, solar output, it is seen that approximately 40.6 is a kilowatt is average which a PV is generating. So optimizing of power generator. So for optimizing power generator, MPPT and advanced controller for PV and wind system increase overall efficiency. The hybrid system ensured a diverse energy mix and maximizing renewable energy utilization. And in this figure we can see the synchronous machine and how it is connected, and the output of the grid power is discussed in the graph. To meet the energy demand, the supply of critical and non-critical load demonstrate the hybrid system efficiency in catering of various energy demands, enable an efficient and stable power supply for a critical load. Overall, the simulation results tell us the efficiency of the proposed integration optimal framework of an hybrid power system for a Pilley's Island, contributing for of renewables energy resources and a backup diesel generator result in good sustainable and good power supply solution for the community and contributing to a green energy future. And in this two graph, the output of diesel power and this wind is shown. In this we can clearly see that wind is producing far more than a diesel, as also we have discussed in previous where PV output was given, which was also more than diesel. So most of our system is based on renewable resources, which is PV and wind power.
So here's the conclusion. The comparison between diesel and solar power systems for Pilley Island revealed important findings. So for an economic perspective, solar power system requires a higher initial investment but offers significant cost savings in the long run. Moreover, solar panels have a long lifespan than diesel generators, further enhancing the economic feasibility of solar energy. In terms of environmental impact, solar power systems stand out as a cleaner and sustainable alternative, while diesel generators contribute to air pollution and greenhouse gas emissions. Also, reliability is a crucial factor, and although diesel generators provide a reliable power source, the integration of battery storage with solar power systems can ensure continuous supply, making solar energy a more reliable solution. Uh, with its long term cost saving, environmental benefits, and potential for enhanced reliability through storage integration, the transition to solar power systems hold promising for meeting the energy needs of Pilley Island in a sustainable manner. Thank you.